Welcome to another custom-tailored deep dive here on behavioral intelligence. Today, we are continuing our journey through Domain C, which is all about measurement, data display, and interpretation.
Yeah, the really fun stuff.
Right, the absolute bedrock. And specifically, we're focusing on BCBA Foundation C.3, measuring the occurrence of behavior.
Which is, one of the most frequently used measurement approaches in the entire field of applied behavior analysis.
Exactly. So our mission for you today is pretty straightforward. We want to take a stack of dense sources, mock BCBA exams, foundational ABA textbooks, ethical guidelines, and extract the ultimate shortcut for you. We're going to figure out exactly how to measure how often behaviors happen using count, rate, and percentage.
Because whether you're trying to crush your upcoming exam or just trying to become a sharper observer in your daily life, getting this right is crucial.
Okay, let's unpack this. Because if we start at the absolute most basic level of measurement, before anyone can analyze a behavior, they just have to count it.
Right. You just tally it up.
But looking at the sources, it turns out that simple counting is actually kind of a trap.
Oh, it is a massive trap. I mean, we define count or frequency as just a simple tally, like literally making a mark on a page every time a behavior happens.
Just 1, 2, 3, 4.
Exactly. The clinical examples in the text are super straightforward. It's like counting how many times a client named Travis passes a basketball during a game.
Okay.
Or a teacher counting the number of cartwheels a child does on the playground. It's just a raw number.
Yeah, but okay, counting behavior is like counting calories. If someone comes up to me and tells me they ate 5,000 calories, my immediate question is, was that in one day or 1 week?
Right, because that completely changes the picture.
Completely. Without knowing the time frame, that raw count of 5,000 is completely useless to me. It could be a binge or it could be starvation.
That is such a perfect analogy, and it completely validates why the BCBA task list strictly separates frequency, that raw count, from rate.
So rate is where we bring time into it.
Yes. You take that raw count and you divide it by the observation time. So instead of just saying a kid read 95 words correctly, which is just a count.
You say they read 95 words correctly per minute.
Exactly. Per minute. And what's fascinating here is how strictly the modern texts separate these two concepts, because some older textbooks used frequency and rate totally interchangeably.
Oh, really? That sounds super confusing.
It was. But now, to truly compare behaviors across different observation periods, rate is the absolute gold standard because, observation sessions are rarely exactly the same length.
Right. Life happens. You might observe for 10 minutes one day and an hour the next.
Yeah. So rate gives you that standardized measure.
Okay, so since adding time makes the data so much more useful, it logically seems like we should just always use rate. Like, why wouldn't I always want that standardized number?
Well, you would think so, but the source is actually explicitly warned against doing that.
Wait, really? Why?
Because it's about using the right tool for the job. Rate is perfect for what we call free operands.
Free operands. Okay, remind me what that means in this context.
It basically refers to discrete behaviors that have a really clear beginning and end, and they take very little time to do. Plus, the person can do them pretty much whenever they want.
Like they're free to omit the behavior.
Exactly.
Yeah.
The mock exams use a great clinical example for this. Imagine an adult in a sheltered workshop who keeps making inappropriate jokes.
Okay.
And it's disrupting the work. A joke takes, 5 seconds to tell? It has a clear start and finish. So tracking the rate like jokes per hour perfectly captures that baseline.
Okay, I get that. But wait, what if the behavior lasts a really long time? Let's say a kid throws a massive, epic 45-minute tantrum.
Oh, yeah, the epic tantrum.
Right. If I record the rate as like 1 tantrum per hour, that completely fails to capture the nightmare of that hour.
Yes.
1 per hour sounds great on paper, but the reality is they spent 75% of the hour screaming on the floor.
I love that you brought this up. This is a huge point. Rate is a terrible measurement for continuous behaviors that extend over a long period of time.
Because it just hides how severe it actually was.
Completely hides it. Tantrums, cooperative play, staying on task, if it eats up the clock, rate is the wrong choice.
Yeah.
And it's also highly inappropriate for restricted operands.
Restricted operands, as opposed to free operands.
Right. Think about discrete trial training, or DTT. The opportunities to respond are limited by the teacher.
Like the teacher holding up a flashcard and saying, "What is it?"
Exactly. The student can't just shout out 50 answers in a minute if the teacher is only showing them 10 flashcards. The environment is restricting their opportunity.
So measuring their rate there wouldn't make sense because the teacher's the one controlling the speed, not the kid.
Bingo. You'd be measuring the teacher's rate of flipping cards, essentially.
Okay, well, here's where it gets really interesting. Because if rate doesn't work when opportunities are limited by a teacher, what are we supposed to use? I mean, the obvious answer to me is percentages.
Yep, that's where most people go.
Because we all know percentages. You take a test, you get a grade. But looking at the sources, it seems like percentages can completely lie to us.
They absolutely can. And they do it all the time in clinical settings.
So just to define it, percent of occurrence is just the ratio of responses to total opportunities, right?
Like you said, answering 39 out of 50 questions correctly gives you a 78%.
Simple enough.
Yeah.
But the text brings up this massive danger with small denominators. And this blew my mind a little bit.
Oh, the small denominator issue is terrifying if you're relying on that data.
Right, because say an observer only tracks 4 intervals, and they see the target behavior in 3 of them. That's 3 out of 4, 75%.
Which looks like a pretty solid trend.
But just one single missed behavior, like if the observer blinks and misses it, drops the data down to 2 out of 4, which is a massive 25% plunge down to 50%.
Yeah, the data just falls off a cliff.
It makes the kid look wildly unstable when really it was just a tiny sample size.
And that's why the sources have a golden rule for this. If you are going to use percentages, they should ideally be based on a minimum of 30 opportunities.
30. Okay.
Yeah, 30 opportunities or intervals to be considered reliable. Anything less, and the math's just too volatile to base an intervention on.
That makes total sense.
Yeah.
But there's another issue with percentages, right? The fluency trap.
Yes. If we connect this to the bigger picture of how people learn, hitting 100% accuracy actually puts an artificial ceiling on your data.
Because you can't get better than 100%.
Exactly. So if a learner hits 100%, the graph goes flat. But what if they're getting faster? What if yesterday it took them 10 minutes to get 100% and today it took them 2 minutes?
The percentage doesn't show that speed improvement at all.
It completely hides it. But the fluency trap goes even deeper. Percentages can actually hide errors.
Wait, hide errors?
The sources outline a very specific mathematical example for this. Let's say a student gets 50% on a math worksheet one day. Say 5 out of 10 questions correct.
Okay, 5 correct, 5 wrong.
Then the next day, they get 60%. 12 out of 20 questions correct.
Okay, so the percentage went up from 50 to 60. Everyone is cheering. The parents are thrilled.
Right, it looks like improvement. But look at the raw errors. On day 1, they made 5 errors. On day 2, they got 12 out of 20, which means they made 8 errors.
Oh, wow. So their total errors actually increased from 5 to 8.
Yes. The percentage improved, but they actually practiced making mistakes more times on the second day than the first.
That is wild. The percentage literally masks the fact that the kid is failing more often in raw numbers.
Exactly. And if you're trying to build fluency, practicing errors is the worst thing you can do. So to truly measure fluency, you have to track the rate of both correct and incorrect responses. You cannot just rely on a percentage.
Wow. Okay, so now that we've exposed all the mathematical traps of rate and percentages, let's pivot. Let's talk about real-world applications and how you, listening to this right now, can use this on the actual BCBA exam.
Yeah, because the exam is going to test exactly these nuances. They love to throw scenarios at you to see if you'll fall for the traps we just talked about.
Okay, hit me with one of the exam scenarios from the sources. Let's see how I do.
All right. What is the best behavioral dimension to use if you are measuring a person's felony convictions?
Felony convictions.
Oh.
Okay, well, I want to know if they're getting worse over time, so my instinct is to standardize it. I'm going to guess rate, like convictions per year.
And that's exactly where they get you.
Oh, no, I fell for it.
You fell for it. Using the strict logic from the sources, the answer is a total frequency count.
Wait, just a raw count? Why?
Because the question didn't provide a time period. A felony conviction is a free operand. It's a discrete event. Unless the prompt specifically gives you a time boundary, like convictions per decade, you are just counting the occurrences. 1, 2, 3. It only becomes a right when that specific time period is applied.
Ah, so I was adding information that wasn't there.
Exactly. You assume the time frame.
So what does this all mean? It seems like picking the right measurement, Whether you're tracking DoorDash orders at a restaurant, or Travis passing the basketball, or reading fluency, it's not just about doing the math correctly.
No, it's not.
It's about matching the measurement procedure to the actual environmental constraints.
Yeah.
Like, does the teacher control the pace? Does the behavior last a long time?
Yes, you have to look at the actual dimension of the behavior. If your data isn't openly observable and unbiased by the tool you're using, it's not valid.
So to quickly summarize this deep dive for you guys,
Yeah.
count gives you the raw number. It's great for discrete events without a set time frame. Rate gives you the speed over time, which is amazing for comparing different sessions, but terrible for continuous behaviors like tantrums.
Spot on.
And percentage gives you a snapshot of accuracy, but you have to watch out for small sample sizes. Remember that rule of 30. And you have to be super careful of the fluency trap, hiding an increase in actual errors.
And honestly, keeping those distinct in your mind is the ultimate shortcut to passing the BCBA exam. But more importantly, it's how you design highly effective ethical interventions in the real world. You have to measure the right thing.
Absolutely. Well, before we wrap up this deep dive, there's a concept mentioned in the sources that I want to leave you with. It's a little provocative.
Oh, the testing effects?
Yeah.
Yeah.
Testing effects or reactivity. We just spent this whole time talking about how choosing the right measurement changes how we understand a behavior. But what happens when the subject knows they are being measured? Think about your own life for a second. How does your behavior, whether it's how fast you work or how often you check your phone, change the exact second you realize someone in the room is keeping a tally?
It changes everything.
It really does.
Yeah.
Something to mull over until next time. Keep diving deep.